Okay, today's lesson will be on polygons in the coordinate plane. We're going to classify polygons in the coordinate plane. So after today, you should be able to classify figures in the coordinate plane using the formulas of slope, distance, and midpoint. So you have a couple formulas you have to use in order to prove something in the coordinate plane is either a quadrilateral, kite, trapezoid, rhombus, rectangle, square, or parallelogram. So you're going to use the distance formula if you want to show me sides are congruent or diagonals are congruent. You're going to use the midpoint formula to determine the coordinates of the midpoint of a side. You can also use the midpoint to tell me if the diagonals bisect each other. So if the diagonals bisect each other, they're going to have the same midpoint for each diagonal. And you have the slope formula, which will tell me if sides are parallel, if diagonals are perpendicular, or if the sides are perpendicular. And remember, perpendicular is opposite reciprocal slopes, and it's also when two slopes multiply to -1. So remember, perpendicular is slope 1 times slope 2 gives you -1. So parallel is M1 is equal to M2, or the slopes are the same. So let's jump right into the first example. So we're going to work with triangles. Let's zoom in. So we can classify a triangle by side length in the coordinate plane. So if we want to tell a person if the triangle in the coordinate plane is scaling, isosceles, or equilateral, you have to use the distance formula 3 times. So a scaling triangle has all sides being of different length. You have isosceles triangle where you have 2 and only 2 sides being congruent, and equilateral where all 3 sides are congruent. So in order to tell me if something in the coordinate plane, or more precisely to tell me a triangle in the coordinate plane is scaling, isosceles, or equilateral, you have to do the distance formula 3 times. So your distance formula is d equals the square root of the difference of x's squared plus the difference of y squared. So here's my first example. I don't know what type of triangle is formed by the following 3 points. I have A, B, and C. So first thing I'm going to do is I'm going to apply it. So -2, 4. So I go over 2, -2, and up 4, 1, 2, 3, 4. So here's A. I have B over 4 up 6, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. And then I have C, which is over 1 down 3. I'll connect them. And again, you can't just estimate or guess visually that this is going to be scaling, isosceles, or equilateral. And you can't assume that angle A is 90 degrees. You're going to have to prove using mathematics. Okay, so if I want to prove sides are congruent, I have to do distance formula. So let's shrink my coordinates down. So I need to find the distance of AB. So distance of AB is the square root of, I take the difference of my x values, so I have -2 minus 4 squared plus the difference of my y values. My y values of the coordinates A and B are 4 minus 6 squared, which gives us the square root of -2 minus 4 is -6 squared plus 4 is -2 squared. So now I square negative becomes positive, so this is 36 plus 4, and this is square root 40. So that's the distance of AB. So now I have to do the same thing. And I need to find the distance of BC. So the distance of BC is the square root of, take my B x coordinate, which is 4, subtract it from the C coordinate, or the CX coordinate, which is 1, add it to the difference of the y-b coordinate, which is 6 minus negative 3, and then I have to square that, which is equal to 4 minus 1 is 3 squared. 6 minus the negative 3 becomes positive, so that's 9 squared. So when I simplify, I have 3 squared, which is 9, plus 9 times 9 is 81, which equals the square root of 90. So right now I have at least, okay, I could have a scalene or isosceles. So to go to the next one, I have to find my distance of AC. So I have to find all my distances. So the AC distance is equal to the square root. I have A, which is negative 2, minus 1 squared, plus 4, minus a negative 3 squared. So negative 2 minus 1 is negative 3 squared, plus 4 minus a negative 3 is 7. So now I can square it. Negative 3 squared is 9, plus 49, 7 times 7. So I have all this added together now is 9 and 49 gives me 58. So let's zoom out. So here we go. Notice that I have square root 40, square root 90, square root 58. So I have triangle ABC is scalene because all sides have different lengths. So you have to do distance formula 3 times. You can't stop twice, and you can't stop at just one. You have to do it all 3 to see if you have 2 the same, or all 3 the same, or all 3 different. So if all 3 are different, scalene. If 2 of them, and only 2 of them are the same, it's isosceles, and if all 3 are the same, it's equilateral. So apply this to our little flow chart. So you're going to use this flow chart to determine the type of quadrilateral in the coordinate plane. So if I give you 4 points and I want you to tell me what type of quadrilateral it is, you're going to use this flow chart, starting with the top. So you're going to start at the top, and you're going to do the slope formula, because if you have parallel, it's slope. So this is slope formula. If you see congruent, this is your distance formula. Again, parallel is slope, perpendicular is slope. So I'm writing down what types of formulas you should use. So distance is used with congruent, perpendicular, slope, slope. One pair of consecutive angles 90 degrees, this will be your slope. 2 pairs adjacent sides, this is distance formula. So if you want things congruent, it's distance. Okay. So if you want to tell me you have a quadrilateral, that's a parallelogram, you're going to show that opposite sides are parallel. So you use your slope formula. So I'm going to erase all this. And we're going to do a couple of examples. So I will actually make this stay. So here we go. First example, I want to classify the parallelogram. So since I already know it's a parallelogram, okay, it's a parallelogram, I already know that opposite sides are parallel. So using my flowchart over here, opposite sides are parallel, yes. How do I know? Because it's already a parallelogram. Parallelogram is on the first yes column side, or the flowchart yes, underneath the first name. So again, to reiterate, the question says, is this a parallelogram, a rhombus, rectangle, or square? Well, Since I already know it's a parallelogram, I don't have to find the slopes of all four sides. So now I need to know, okay, are the diagonals congruent? Well, if I want to show if the diagonals are congruent, I have to do the distance formula. So I need the distance of A to C. So the distance of A to C is going to equal to the square root of A negative 2 minus 4 squared plus 0 minus 5 squared. So we have negative 6 squared and we have negative 5 squared. So we have 36 and 25. When I add them together, remember this is all under the square root, I get the square root of 61. Now I need to find the distance of BD. Again, I need to show diagonals are congruent or not. So distance of BD is the square root of B0 minus 2 squared plus 4 minus 1 squared, which would be negative 2 squared plus 3 squared, which is 4 plus 9. I'll make the square root, which gives me square root 13. So square root 13 and square root 61, they're not the same. So my diagonals are not congruent. So going over to the flowchart over here. So I know it's p-gram, so it's a yes. Diagonals congruent? No. Okay, I'm circling no. Now I need to check, are my diagonals perpendicular? So are my diagonals perpendicular? Well, if I want to know if something's perpendicular, I have to have two slopes multiplied by negative 1. So I need my slopes of my diagonals. So I need my BD slope. Well, I'm just going to use the graph, BD slope. So I know my rise is 1, 2, 3. And my run is 1, 2. Negative 2. So there's my slope for BD. I just use the graph. You can use the equation, okay? Difference of y's over difference of x's. But since I already have the graph, I'm just going to use the slope using the coordinate plane. Now I also need my AC slope. So I need to find my AC slope. So A to C, I go 1, 2, 3, 4, 5. And on 5, the slope is rise over run. Now I run over 1, 2, 3, 4, 5, 6. So those are my slopes. Notice that these slopes are not opposite reciprocal of one another, and these slopes don't multiply to negative 1. So my diagonals are not perpendicular. So they're not perpendicular. So what is this? It's a parallelogram. So this is neither a rhombus, rectangle, or square. It's a p-gram parallelogram. So my shape is a p-gram. Let's try another example. So I keep vertices. I want to know what type of parallelogram this is. So I have M, which is 0, 1. So I'm going to plot 0, 1, which is right here. I have negative 1 over 4, 1, 2, 3, 4. I have over 2 up 5. And I have over 3 up 2. So here is M, N, P, and Q. Let's connect them. So it looks like a square, but we can't assume until we do the math. So, since I already know it's a parallelogram, I already know my opposite sides are parallel, so I'm already right there. I'm already on the S side of the flowchart. So now I need to do, are my diagonals congruent? So I need to know, is NQ equal to PM? Well, how do I show two things are equal in length in the coordinate plane? I do the distance formula for the diagonals. So let's draw in our diagonals. So here are the diagonals. Okay, you're not doing the slope yet, you're doing the distance formula. So I have NQ distance is the square root distance formula. So N to Q, I have -1 minus 3 squared plus 4 minus 2 squared, which equals -1 minus 3 is -4 squared plus 2 squared. So -4 squared is 16 plus 4, which gives you the square root of 20. So there's NQ, distance. Now I have to do PM. PM is the square root of, so I take the x value of the P, which is 2, minus in the M, 0 squared plus 5 minus 1 squared. This is 0. So I have the square root of 2 squared plus 4 squared, which equals 4 plus 16, which equals square root 20. Okay, so notice that my diagonals are the same. So yes, diagonals are the same. Now I have to do, are my diagonals perpendicular? So is NQ perpendicular to PM? Well, how do I do that? I have to do slope. Okay, so let's go back, turn off this dual display. So let's do slope. So I want to know, is NQ perpendicular to PM? So I have to do my slope. So I need to have NQ slope, and I need PM slope. So let's go back up to my graph and do NQ slope using rise over run. So N to Q. I always start, when I do slope with in the coordinate grid, I always start at the lowest point on the line. Go rise and then run. So it's always up, knowing it's positive, and left and right. So N to Q, I go up 1, 2, over 1, 2, 3, 4. So that's 2, -4. So this is 2, -4, which is 1 over -2. So that's my NQ slope. Now I have to do my PM slope. PM, I go up 1, 2, 3, 4 over 2. So this is 4 over 2, which is 2. So notice that I have -1/2, and if I times it by 2, I get -1. So if you multiply two slopes, here's slope 1 times slope 2, that's -1. If that's true, it's perpendicular, and this is true. Therefore, those slopes are perpendicular. Therefore, I know that the diagonals are going to be 90 degrees. So this is, yes, diagonals are perpendicular. So going back to the flowchart, my diagonals were perpendicular, so it's a square. So it's a square because the diagonals are congruent and perpendicular. Let's do another example. So I want to know if this is a rectangle. Now, if I want to know if this is a rectangle, I have to do the first step in the flowchart, which is, are these sides that are opposite of one another parallel? If it is a rectangle, it's a parallelogram. So to answer this question, I have to first show it's a parallelogram. If it's a parallelogram, I do the rest of the flowchart. So let's bring up our flowchart. So here's our flowchart. So, is it a rectangle? Notice that I don't tell you it's a parallelogram. So you have to start at step 1. So here's our flowchart. You have to start here. You have to show me that two pairs of opposite sides are parallel. So, is RQ parallel to ST? And I want to know also, is RS parallel to QT? Well, if I want to know if something's parallel, I have to do slope, which is rise over run. So let's do RQ slope. Remember, lowercase m in math is representing slope. So R to Q. So it's rise 1, 2, 3, 1. So it's 3 over 1. ST slope is up 1, 2, 3 over 1. So same slope, yes, they're parallel. Next thing I have to do, okay, RS slope. So R to S, up 1 over 1, 2, 3, 4. So that's 1, negative 4. Now I have to do the QT slope, which is up 1 over 1, 2, 3, 4. So that's 1, negative 4 also. So yes, they're parallel, so I know them right here. I knew, yes, the two pairs of opposite sides are parallel. Now I have to do, are the diagonals congruent? So, step 2. Are the diagonals congruent? So, is QS equal to RT? Let's turn off the display here. So let's do this. I need to know, is QS and RT the same? Well, let's go back up. I need to know that Q I need to get the coordinates. So Q is at over 1, down 1, so that's 1, negative 1. I have R, which is 2, 2. I have S, which is 6, 1. And I have T, which is 5, negative 2. So I'm just going to take these, bring them down here to work with it. Okay. So I want to know, are these diagonals congruent? So let's use your distance formula. So I have Q, S, distance. So QS distance. I have 1 minus 6 squared plus 1 minus 1 squared. 1 minus 6 is negative 5 squared plus negative 2 squared, which equals negative 5 squared is 25 plus 4, which is square root of 29. Now I have to do the RT distance. So RT. So I have 2 minus 5 squared plus 2 minus negative 2 squared. Simplify. 2 minus 5 is negative 3 squared plus 2 minus negative 2 is 4. So negative 3 squared is 9 plus 16, which gives us 9 plus 16 is square root 25. So these are not congruent. Okay, so these distances are not congruent. So again, look at it. We have 1 minus 6, which is negative 5. Then we have negative 1 minus 1, which is negative 2. Get square root of 29. RT is 2 minus 5. Which is negative 3 squared, and then you get 2, which is 4. So my diagonals are not congruent. So if they're not congruent, I know automatically it's not a rectangle. So this is not a rectangle because diagonals are not congruent. Zoom out. So again, first thing you have to do is prove that the opposite sides are parallel. And then I have to prove that diagonals are congruent for a rectangle. Since the diagonals are congruent, I can stop. I'm not asking you what type of shape it is. I just want to know if it's a rectangle. So it's going to be no. And that concludes this lesson. If you have any questions, please see me, email me, or ask during class.